that.
You know what I'm gonna do moving forward, Shauna?
This meeting is being recorded.
What
What
I'm
was
gonna
that?
do moving forward is that I'm gonna take screenshots of all the examples because it gives you an option to view an example. So I'm gonna take screenshots of all the examples for all the problems I work on. And we can always refer to that. Like for
So
this one
here's
is I know
here's the step. So it says substitute any variable x with x plus h or x plus delta x. Subtract the original equation from your current equation, divide by h and substitute h for 0. Okay, so basically here's what it's saying. You've got your equation, you substitute it, you factor out, then once you get that equation, then you write them separately and divide by h, and then you simplify.
yes, that's the one. Yes.
So it's the difference quotient, but she just breaks it apart differently. But these are the 4 steps here.
Yep.
These are the 4 steps she's talking about.
And what I'm gonna do moving forward is that I'm gonna, for every like sample problem, like similar problems, I would put them in a Word document because we can always, But you're right. It's a quotient rule because I do see the H right
It's
there.
called, be careful, it's not the quotient rule, it's the difference quotient. They're different.
The difference quotient.
They're different. The difference quotient.
That's the one. Okay. Yeah.
The difference quotient. Yeah, don't mix up that terminology because then when you read the question, you'll be, what is
going on here?
The difference quotient basically says that you're getting the tangent line close to the secant line. So those 2 lines are approaching each other. And as they approach each other, you're finding the limit as that distance goes to 0. And that is in fact the slope of the tangent at that point. That's what this refers to. Okay.
Got it.
The difference quotient itself is a formula for finding derivatives when your function is a quotient. Okay. So they're a little bit different. The terminology is similar, but that will confuse you if you mix up those 2.
Oh, yeah. Yes, they will.
So just be aware of that, okay?
Well,
then it says, okay, so we're using the 4 steps a few times, finding the slope of the tangent line, find the instantaneous velocity function. Then we've got some algebra down here. Then you want the derivatives of some functions, some basic functions, not a big deal. Find h prime of t. Okay, that's a polynomial. Okay, these are like for 30 and 31, for example. These are quotients. So you would use you can use the division, the division rule for derivatives, the quotient rule for that. You can use the quotient rule here. Okay. You could use the difference quotient, but normally by the time you get here, you're using the quotient rule. Okay. To do that.
Got it. Let me grab. printed some stuff up at work to help me.
Is there anything in particular that you would
Here,
like?
I think for now, I want to focus on section 2.6 because
Which
I haven't
is-
covered that. Yeah, and then I can start practicing on this ones.
Okay.
And then I'll let you know which ones I need help on.
Okay. Not fair enough.
So we're good. Just wanted to give you a little intro on that one of what is coming up.
Yeah, it looks like you're about half to 3/4 ready right now for that.
And I'm going to open my section for my 2.6 and we can start working on some of those problems.
Okay.
And I'll let you know what that is.
Have you did you start working on this and have one of those moments where you didn't know what was going on? Is that what was happening or?
No, I haven't even touched on 2.6.
Oh, okay.
Because there's a lot of those problems with the little triangle.
Delta.
The delta.
X. Right.
The delta X. So this section has 12 problems.
Okay.
But let me open it and then we can get started on this. I don't know how many of these problems are in the exam. I don't know, maybe when you look at it.
Yeah, as soon as I kind of see what, then I can kind of tell you.
Yeah. So this thing, it's taking a little time to open. So here it goes. I'm going to begin sharing my screen. And then we can start working at these problems. Let me click share screen. And then this is where we want to be in 2.6. I know it's not opening.
Okay, I see it says.
I'm gonna probably have to turn off my camera.
I see it says Zoom, but we need to. Okay, you are screen sharing. Okay, what I'm seeing is myself on your screen. Now I see homework question 1 for y equals f of x 7x squared, find x delta y over delta x given x1. Okay, so this is setting
you want me to
up. Huh?
You want me to click you an example or we're good to go?
No, I'm okay. I see what I'm gonna show you what they're doing here because
yes.
f of x is equal to, this is getting you ready for the tangent line versus the secant line and the point and all of that. So f of x is 7x squared. We want to find delta x. We want to find delta y. We want to find delta y over delta x. This is one of those cases where the way that Pearson's doing it is making it harder than it actually is. It's not meant to do that, but it's making it harder in a sense than it is. This is 1, and this is 5. It's setting you up because they want to emphasize the difference between a tangent and a secant line. So what I'm going to do here, I'm going to do this. I'm going to turn to, give me a second here. I don't want to minimize you, but I do need to move this and I need to close that and close this and close a few other things. Just do some house cleaning here. All right, let me go do this. bear with me for a minute.
Of course, yeah, take your time.
So here, I'm gonna get us in. I want to try it. So I'm gonna go to.
Sometimes I wish I had like 5 monitors.
I know the feeling.
Right.
Okay, so here is, let me share the screen.
That's fine.
You do not have to, I want you to know, you do not have to graph this to do this, but I want to, okay, wait a minute. Where is, okay, there I go. Here I am. You don't have to graph it. I'm going to show you what this is doing. This is why I did this way. So I'm going to come down here. Now, what I'm going to do is I'm going to set this up to graph for us on the, let me get rid of my bar. Can I get rid of my bar? Close. Okay. Now I'm going to set up this screen here. We're going from, I'm going to go from 1 to 5. Okay. So 1 to 5. Scale this by 1 unit. Okay. I'm going to scale the y-axis by 7 to, I'm going to do, this is going to be, I'm going to go from negative, I want to go from 0. If that's 7, that's going to be like, what's that? 350 something. Scale this by 25 units. Okay, something like this is my scale. Actually, I'm going to go back to so we see the axis here so that it can look a little bit more -5, just so we can see a y-axis. So I'm going to graph the graph they give me. Y equals 7x squared. I just want to show you what they're asking so that you understand what this is saying to you. So here's the graph. Okay. Now we're actually looking at the graph from 0 to 5. So I'm going to move this over because I don't care about the right hand side of this right now. I'm going to move it up just a bit. So we're actually looking, for our purposes in this problem, our x1 is, let me change to green here. Our x1 is this. X1 is 1, okay? And x2 is 5. Okay? So we're looking for our purposes at this part of the graph. Now, the graph is a parabola. We know that it has a domain of all rails, but we're restricting where we're looking, okay? Now, delta x, the first part of this, delta x means the change in x, okay? And so that just means the x2 minus x1 is all that means. Okay?
x2 minus
x1 is delta x. Okay? So delta x, remember at 1 is, they give you x1 and x2. So x1 is 1. and x2 is 5, right? Now, what this represents graphically on the graph is the distance that you're looking at on the x-axis. So basically, it's asking you how far apart are x1 and x2. Now, you could count that, but you can't usually, so we go ahead and write it. So x2, they give you as 5. So this is 5 minus x1, which is 1. So 5 minus 1 is 4. Okay, that's 4. Okay.
Right.
Now we're going to do delta y. So delta y is similar, but delta y, let me show you what delta y is. I have to erase. My x1 was super long. I'll show you why I had to modify this. You'll understand this in just a minute. Here's x1 right there, right? Now, y1, let me go and make, what should we make? How about we make black? Okay, so y is the point that's actually on the curve. Okay, so delta y is actually that point there and this point here. All right, there they are. Okay. Now, these don't show up nicely to tell us because of my scale, but the way you get it, we know what the function is. See, we know it's 7x squared, right?
Yes.
So
7x squared.
Delta y is going to be similar to delta x, except we're going to have to do a little bit of calculating first. We need to know what y2 is, and we need to know what y1 is. Okay, so y2 is going to be the y coordinate here at 5. This is 5, remember? X2 is 5. So this ordered pair over here, this ordered pair is 5 and something, right?
Got it.
Well, in order to figure out what that something is, we plug that into x. Okay, so to get y2, we can say y2 is equal to f of 5 because it's f of x2, right? And so that's equal to 7 times 5 squared, right?
Times, okay, yes.
Everything good so far? Do you understand where we're going?
Yes.
So if you do this calculation, 5 squared is 25. 7 times 25 is 175. Okay. And you can see that on the graph. If you look.
Oh, yeah, because it's going up.
Right here.
It starts at 5. And then it's like its limit, we can say.
Well, no, it's not a limit. That's the actual value this time.
The value, okay.
This is the function value. But the limit would be that if we were calculating the limit, but this is actually the value. Don't think about the limit for this. Think about the actual fund. And I have a reason for telling you that because it's going to, this is on the actual function, okay? you're gonna get to some that are on what we call the tangent line or on the secant line. I don't want to get you confused. That's why I'm trying to be really careful about my wording. So this is actually on the phone. This is 5 and 175, right? Now, so this Y2 is 175, right?
Yes.
So now, what
so
is
I have a question. I have a question before we continue. So what you wrote here, that is like the formula. The delta Y equals Y2 minus Y1. This applies to every problem like this?
So far, unless they are doing something with, sometimes it's
at least for this chapter, it's good,
yes,
right? Okay.
it should.
Yeah, I don't want to think ahead.
It should be, yeah. And I don't know how much detail they're going to go into, how fast, we'll find out.
Yeah.
But yes. Okay. So I don't want to make any guarantees, but you'll see as we go. It'll make more sense as we go along. So now Y1 just means, remember X1 over here? Okay. What we're trying to do is find that corresponding Y, right? So where is that? Well, that's 7. How do I know that? Because this is f of 1, okay? And if I plug 1 into the function they gave me, I get 7 times 1 squared. And that's just 1 squared is 1, right? And so that's 7. Okay.
Okay.
Now, the last part of what they asked you is what is delta Y? So the last part of what they asked you was this. You found delta X, you found delta Y. Well, we haven't quite found it yet. I take that back. We need to do one more step. So to find delta Y, to actually find it, we need to actually do the calculation, right? So delta Y is going to be Y2, which is 175. So this is going to be 175 minus Y1, which is 7, okay? And that's going to give us 168. This is 168, okay? So far, so good?
Yes.
Okay. Now, what I'm going to do is I'm going to draw a line here so you can see what's going on. So here I have a line between X1 and X2. See that? So there's my, now what I'm going to do here is this. I'm going to take my, okay, I'm going to show you something. Because I know this is overkill right now, but trust me, the more you understand this now, the easier it'll be later when you start doing secants and all of, you'll understand what it actually is. Hopefully it takes a while, but I think you'll get it. This part, I made this in 3 colors for a reason, okay? Because I want you to recognize something from algebra. This should look familiar to you, okay?
Yes.
Now,
geometry.
this X2, see the bottom green line? The green line at the bottom here?
Yes.
That's 4 units.
4 units, correct.
This red line, because I had to draw my scale, notice my scale on the y-axis is larger, right? It's 25 units for box. So this is actually 168 units tall. Okay. This is 168 units. From this top point right here to this bottom point is 168. Okay. So delta X is how far is it from those 2 points horizontally? See, they gave me 2 X coordinates, 1 and 5, right? How far is it going left to right? It's 4 units. Delta Y is how far is it from the bottom to the top?
175.
Which is 168. No, 175 is not the distance that they are apart. It's the distance that this was. Delta Y is this distance here. The difference between, which looks like 0, but it's really 7, remember?
Yes.
Because it's really this line here, okay? Now, the next thing they're going to ask you to do, and think back to algebra for this, dust off your algebra skills, okay? What is delta Y over delta X?
Delta Y over delta X. So delta X, it's 4.
Right.
Is
so
that
this is, yeah, okay, you can give me that. I am looking for something else, but that's not wrong. Keep going.
So it will be 168 over
168 over 4, right? Okay, I agree. And what does that represent?
The change.
Okay. The rate of change, and what's another name for the rate of change?
The rate of change, what's another name for the rate of?
Look at the picture, look at the black line.
The distance.
What are you finding here? No, you're finding the slope of that line, aren't you? Because isn't slope delta Y over the change in Y over the change in X?
Let me write that down. That's a slope.
Yeah, that's the slope. Now,
change of Y over change of X. That is my slope.
The change in Y over the change in X. Now, here's the thing. This is the slope that you've done in algebra. It's just in different notation than you're used to, some of it.
Yes.
But the reason they're having you review this is that this is what we call the slope of the secant line when you have 2 points. We know how to do this already, okay? What's happening, and this is why I wanted to kind of introduce this, what's happening with the difference quotient is, let's say we want to find I can find the slope between any 2 points easily, because what happens is I just move this black line, right? If this X moves, like if I draw another line, let's say I drew another line.
So my black line, it's the slope.
Well, it's not the slope. The slope is how slanted this line is.
Yeah, got it. If it's more, yes.
So if I were to pick, watch, if I were to pick, let's keep X2 there. So let's keep X2 where the blue dot is. Let's move X1 up the curve. Let's move X1 to right here. Okay. Now what happens is this. I get a different slope, right? Because what happens is that now my triangle looks like this. You see?
Okay.
And so my tangent, my line here becomes a lot closer to the curve, doesn't it?
Yes.
And the closer that this point, the closer that this point moves, the concept where they're taking you, okay, this is the concept they're taking you to. The closer that this point gets to this one, okay, the easier it is for me to find the slope at this single point, right? Because I need 2 points to find the slope. So what I do is I get as close as I want without ever actually touching that point. And that's the slope of the tangent line. Right now you're doing the slope of the secant line. So
my secant line is the curvy one?
Your secant line is the black one.
That's my secant line.
Your graph is the curve, which is in the lighter red.
Okay. Got
and
it.
The blue one is what happens to your secant slope as you move the point. We'll talk more about it, but that's where this is going.
Got it. Okay, my secant line, my slope. Okay, got it. Got it.
Okay, they both have a slope. Okay, the tangent line has a slope, the secant line has a slope. Slope is always this. Okay, except that you'll discover that when you do tangent lines, you need the limit, which is where the difference quotient comes in.
Oh, okay.
Okay, that's how it's connected. All right.
That's where they come up with these numbers.
So delta x is 4. Okay.
Yes.
Delta y is 168.
Yes.
Okay. Delta x over delta y is going to be 168 divided by 4, which is 42.
Yes, 42. That is correct.
Does that clarify a bit? I know that was a lot to put on you, but I'm trying to give you enough background.
No, but I like how you did the graph because it makes sense. It's just a way of like maybe connecting those dots and really understand what it means.
There's a lot of nuances that you have to understand to do this.
Yes. But this gave me, no one had ever explained to me, or maybe I didn't put attention. My tangent line, my what is the other one you mentioned? Secant line?
The tangent line and the secant line, okay?
Secant. Yep. And yeah.
Do you want to try the second one?
Yes, like we can try the second one.
You can share the screen again.
Okay. So this one is 42. The answer we said, let me look at my calculator.
Did they give you more than those ones?
It's 42.
Delta x, delta y, and delta y over delta x. So
first it's asking for delta x. So delta x is
4. Delta x is 4. Delta y was 168.
Let me go back.
I'm not seeing your screen, by the way.
Yeah, it said I had started another window or something. Okay. Delta X is 4. Well done. And then delta Y
was 168. 168.
5. Okay.
And then
delta
Y over delta
Y
X is 42. The final answer is 42.
Yeah, that went through. Oh my goodness. All right. Let's look. Let me share number. I'm going to share my screen so we can take a look at number 2. Sharing. And I think with this will give me a very good understanding of my next ones. You see it here?
Not yet. It says you started. There we go. Okay, now here it says for y equals f of x 4x cubed, find f of x1 plus delta x, f of x1 plus delta x minus f of x1 over delta x. Given that x1 is 5 and delta x is 2. Delta x is 2. Okay, so this is more about how to write how to understand what you're looking at than it is. It's building you up to the difference quotient that you've already done, pretty much. But it's making it a little bit hard, like I said. So this says that you have, and it's 4x cubed. Is that the function? Is that what it said? I forgot to write the
4x cubed. Yeah, the function is 4x cubed.
So f of x is 4x cubed, okay? And we're wanting to write our, this is our difference quotient essentially. So what we're doing is we're writing the, let me draw this out. So this is f of x1 plus delta x, x1 plus delta x minus f of x1, okay? So now it tells you what these are, okay? So you plug them in and then you simplify. So, I mean, that's one way. You could do this with all your deltas. So you could just use the function and cancel all your deltas. But since they've given it to you, you can just plug it in if you want. So there's a couple of ways to do this, all right? But they give you x1. So x1 is 5. So this is basically saying f. Now I'm going to do it the short way first, just to show you, okay? x1, we know is 5 units. They told you that. That's 5, right?
Yeah. Yes.
Delta x is 2 units. So this is 2 here, right? minus f of x1, okay? Well, x1 we know is 5 units. So this is f of 5. And delta x is 2. You see that? Now, 5 plus 2 is 7. So this is f of 7. F of 7 minus f of 5 over 2, isn't it?
Yes.
Are you with me so far?
Yes.
Okay.
5 plus 2. Yes.
Now, we were given an f of x. So we can find f of 7 and f of 5, right? So I'm going to come over here and I'm going to find f of 7 now. Well, f of 7 means I plug in 7 where I see x. Okay, so that means what I'm going to write is I'm going to say that this is 4 times 7 cubed. Okay, 4 times 7 cubed. And I can...
I have a question.
Yes.
So once we're done, I see the step 1 where we plug in, and then 2, which is f of 7 minus f of 5 over 2. Is that where we stop and plug that into the function?
Yeah.
Okay.
Because
So we don't...
I need to know what these numbers are before I can subtract them. This isn't 7 minus 5. This is f of 7. This is the function evaluated at 7.
Okay.
Minus the function evaluated at 5.
Oh, got it. Makes sense. Yes. Yeah, you can keep going.
Okay. So now we're going to get our calculator. What is 7 cubed times 4? Let's pull up the calculator here.
Times what?
7 cubed times 4. So let me share the screen.
1,372.
So I have, let me see, this is going to be, so I'm going to take 4 times 7. I want to go to the third power. I know how to do that. All right, so I'm going to go here, close this. There's f of 7, right? F of 5 is just 4. This is 5 cubed. This is 500. So I have 1372 minus 500 over 2. Okay. So now, questions about this part?
Nope, we're good.
Okay. So here, this becomes, this was 1472. Should be equal, not minus. Equals. Okay. This is 1472. Or 1372, sorry. And this one is
f of 5.
f of 5. So I'm doing the same calculation with a different number. So this is 4 times 5 to the 3rd power. 4 times 125. That's 500. Okay. Now, this is equal to 500. This is very reminiscent of the 4-step process right here. It doesn't look like it, but it is. It
is because you have to do the
right?
difference of quotient. Yeah.
And then you're going to do this. You're going to say, well, that's 1372 minus 500. Whoops, 1372 minus 500, all divided by 2, because 5 delta x is 2 units, right? So then you have 1372 minus 500. That's going to give you 872. And 872 divided by 2 is 436.
Correct. Yep. We're good. Okay.
Now I could have, that's the short way because they gave you all the numbers. Okay. If they hadn't, you would have had to do all the algebra with the, you told me there's a lot of delta x's. That's where you would have put in f of x plus delta x. You put in 4 times x plus delta x to the 3rd, expand it all out, subtract 4x to the 3rd, factor all the delta x's, cancel, and then combine everything and find the limit.
All right.
But because they gave you the numbers here, you didn't have to do any of that. It's heading there. It's heading to that. But this is just a warm up to that.
Okay. Okay.
Is that helpful to you?
Yes. Yes, it is. Very.
Okay.
Okay, that made a lot of sense. Like I would not have had an idea on how to start, especially that first one.
There's a lot of terminology hanging out. I would suggest that you send me the homework. You can, because that homework you should be able to print without a problem.
Yeah.
That way I can, if you get a little stuck, I can look at it and be like, this is how it's going. This is what we're doing.